Good morning. Okay, this is going to be now session 6. I think we're going to call it 6A though. In this series, in the previous 5, I've led up to this final portion, which is going to be giving a pretty careful preview of the 6 major mathematical elements of this work. And I think I'm going to end up maybe calling this Sphereland Rescue. It's a hard word to say, sphere. Expanding ball, because that idea that our universe might be like an expanding ball has been has gotten into trouble. So this long history of the Flatlanders, starting back in the 1800s, and then being migrated to the surface of a sphere, carrying the idea that our universe might be like that. There might be an additional spatial dimension that we can't perceive. And that has got into trouble, which I think I indicated with the Kobe data that says that can't be possible. But this work rescues that idea through the idea of an inner dimension, which in fact is a growing web. So the mathematics of a web really has 6 new components to it that you won't find in the books. So this section 6 was the idea was to review that, and it's just a little too much for one video. So I didn't want to do too cursory of a review or preview. So this will be just part A that we're doing here today. So here in slide 005, you see the picture of Flatland and Sphereland, and based on that, we're going to be looking at a Flatlander rescue. And in the larger picture, this is really about 4-dimensional mathematics that does apply to a universe our size. But here I think this is going to focus on just the lower Sphereland idea because there's no controversy with it. So we're going to have a brief overview of this, and the rescue is really where we had before. In our culture, we have the Big Bang and space-time. Here it's more like a big blossom and relation space. So it's different mathematics altogether. And I should say too, with tremendous alignment with the data between relation space and space-time. They're just 2 radically different geometries. Image 010 just illustrates a globe, a balloon expanding, a sphere expanding, and really the creatures, this is really about the surface of it. It's like a thin membrane, so you have little flat 2-dimensional creatures. The sphere is taken to be so huge after it grows. It's so huge that any little section where inhabitants are is just flat, like Texas is flat on our globe. So there are 2 different pointing directions. You can just go forward and back, left and right here. The radius of this thing is increasing. But notice that you have an axis. You can have an axis coming out to a point on the surface, and that axis is specified by 2 angles. So this picture looks like a globe, but it's really, the emphasis is on the thin outer membrane. So this will be about this expanding globe. One thing I want to emphasize about this expanding globe is that in the stories, Flatland, if you read Flatland, it's just got all kinds of things in there about the shapes of things, the shapes of these creatures. The women are like needles and the men are the various sided, polygons. And there's a whole thing about the society in North and South and how things are distinguished. And Sphereland is the same thing, but those creatures are transported to the surface of a sphere. But this work really cuts through all that because we're just considered atoms. We're going to say, well, everything's made out of atoms in these in Flatland and Sphereland. And we're going to think about just the atoms. So all of that cultural dialogue and dialogue about shapes and all of that is really irrelevant in this. We're just interested in the geometry of this place, this sphere land. So we're going to talk about what atoms look like. Now let's walk through image 015. You see the globe there, and that picture is of a flat atom, and you see it's located on an axis. And as the balloon expands, substance, just if you expanded a balloon that had holes in it and you somehow could make it expand, then air would rush in. That's the same idea, but substance rushes in through the center of that atom. So looking at these boxes here with descriptions on transitional thoughts, the creatures are made of atoms, and a flat atom would appear to be like a tiny circular disk if there were flat land scientists or sphere land scientists. And it would appear to be a cauldron of behavior on the inside because substance is rushing in from the expansion. So, the location of an atom on an expanding surface, that's very, very difficult to define a location. But here you see that the location is angular. It's defined by that axis, that angular axis. So that's the general idea. And from that, we'll go up one step here, although we're going to focus mainly on this case of sphere land. Occasionally, we'll go up one dimension where we're talking about something that's the dimensionality of our space, where it would be like a four-dimensional ball, which is impossible to imagine. We're just going to, a few times in this, step up to that to make some comment about the generalization of this. So here we see a flat atom that looks like a cauldron of behavior on the inside. And in the next slide, we'll see the same kind of thing would be true of our space. Here in slide 020, you really can't imagine a four-dimensional ball, so we can't imagine what that looks like. But we can imagine an atom in the space of Poynting dimensions, which is like our atom. And we do indeed see our atoms to be a tiny sphere that's like a cauldron of behavior on the inside. So creatures and things are made out of atoms, like we are in all objects. And atoms appear to be a tiny sphere with a cauldron of behavior. So within this kind of space, location of an atom would be angular with three angles. So later we'll see that seems like, on the face of it, to be an impossibility in our universe to specify location by three angles. But later we'll see that it is not impossible. So I'll stick my head in here again. One of the central problems in physics that came up with relativity, that problem is a problem of mapping the location of things. And in relativity, it's a little bit complicated, but the bottom line is you just can't do direction and distance between two objects. It doesn't work because time is involved in there too. The same thing is true of an expanding surface. If the surface expanding, then everything is like moving. If you put two dots on the surface, then they separate just as the thing expands. So the only type of location that makes any sense is angular location. And for some reason, it has not been pursued in our history of discovery, or if it has, it's been dropped for some reason. But it actually works very well, and so later we'll get into angular location. The point I wanted to make is that mapping is the big difficulty. And so mapping in sphereland is a difficulty. And so this idea of thinking of a flat atom and thinking of it as located on an axis is a productive idea. So we're talking about an expanding universe, and we're thinking of this sphere as expanding. But there's a subtle change going on here that I want to make note of right now. In this type of universe, all of the expansion comes through individual atoms. The individual, as we shall see, as the atom expands, substance is pulled into it, and then it goes out from there tangentially in the sensory direction. So in our case, for example, as an atom expands, substance that is really, really fine substance is pulled in by the atom and then goes out in every direction at the speed of light. In the sphere, it's going to go out in the tangential directions at the speed of light. So that's a subtle point, but it's really a big one. When you think of space expanding, there isn't some big thing that is getting bigger. What it is each individual atom is growing radially and tangentially by the same amount. So the individual atom is the source of the expansion. So that we're going to do a construct about that now. Image 040 now illustrates that. You can see that around that axis we've made a little tube, and as the as the atom expands, that tube grows out and gets larger, a larger radius, and primal energy, which we call R flux, relational flux. Flux is just a normal term that's historically used for something you don't really understand. But primal energy in the form of that substance flows into that like a straw. And later we'll see that half of it goes out in all the tangential directions. So the atom is growing from the source. It stays connected to the source. As it expands radially, substance comes in, primal energy, and flows out in every tangential direction. Let's see if there's anything. Yeah, so the spinal body is like the in here participant, and it enables collective behavior with the other ones out there, because substance that comes in, half of it is going to flow out in the tangential directions. Image 045 just emphasizes that we're starting to see here the things that we recognized, that we mentioned early in our observations during this series, is that we've got an in here thing, that's the spinal body. We've got an out there, the surface pointing directions, the surface of the sphere. We have participants that got the center. We haven't said what it does, but the center is a participant. Expansion is, the spinal body is, the substance coming in is. All of those are participants in collective behavior. So the aspect of joining, that's going to come a little later. It says come next in here, but it may be in the next actual video. But we're going to have substance that not just flows into that atom, but it's going to flows out in every direction. So it actually will cross over other spinal bodies, and through that they engage in collective behavior.